So in Euclidean geometry, it is divided into properties of quadrilaterals, which is grade 10 work, and then circles, which is grade 11, and then triangles, which is grade 12. Okay, but in all of them, you need to reason correctly. When you are dealing with the problems, you need to write your statement and then provide a reason, and we have a list of acceptable reasons because we can't use our own reasons, right? We must use the list of acceptable reasons exactly as they are. Now this topic, how I usually attack it, especially with grade 12s, is that we need to just solidify the knowledge from these two things. We need just to solidify the knowledge from previous grades, meaning we need to revisit our 9 theorems. So before even revisiting those 9 theorems, let's perhaps start here. What I've realized, right, in my years of teaching, now I can call it years, in my years of teaching, is that most students, they struggle with naming angles, and because of that, that's where the greater struggle becomes. And that's where someone starts hating Euclid, right? EFGHI. Let me put 1, 2, 3, 4 there, and then let me do that. Let me do this. Let me do that. Then let me do this. Let me do that. Let me do this and that. Right. Now, those who I have taught grade 11, they know that the first thing that I'd like to ask is, especially when you're dealing with angles, you must first start by telling me what is an angle, right? Let's start there to say what is an angle. It might seem like something that is minute, but it's big. If you understand what is an angle, then it's easy to relate, or rather to describe angles that you see on a diagram. So, an angle, what is an angle? A space between two lines which meet at a corner or at a point. So, my grade 10s, I always say an angle is a V, right? It's just the space between the V there. That is what is called an angle, and we measure that angle in degrees. Okay, so an angle is simply a V. Now, describing that angle means that you have to look at the lines that are forming the angle. You have to look at the lines that are forming the angle. So this V here will give you the lines so that you can describe or name this angle. So if you name this angle will be A, B, C. It will be angle A, B, C there. Okay. Or you can call it angle B. To say, if you say angle B, you are saying the angle it's formed at the corner at B. Okay, so this is the angle there. Or you can call it angle ABC, or you can even call it CBA. Right? You can call it CBA. That becomes your angle there. So here, if I were to describe this angle, what will be that angle? This one here. That angle would be, you can call it BCD, or you can call it what? DCB, right? DCB, or you can call it DCA. You can also call it DCA. Means your V the V that you'd be looking at would be this part here. Would be this part here. That would be your V, and your angle would be there. So you can call it DCA, or you can also call it ACD, still to describe that angle there. Or you can also call it ACD, right? You can also say ACD to say ACD. That still describes this angle here. Or you can also call it just angle C, because that angle is not divided. Now, calling things angle C or angle B or angle A and stuff, I usually advise that you do that if the angle is not divided, because if the angle is divided, just like here, right? If the angle is divided, you want to be a bit more careful, right? So on that angle that is divided there, if I say to you angle A, what am I referring to? I'll be referring to this angle here. I'll be referring to this angle here, the whole of angle A, meaning that the one that is made up by this V. Okay, so it will be angle A. That is the whole angle. The red part here that you see, this red part, it's not angle A, good people. So you have to be careful. That red part is not angle A there. Angle A is the whole angle here, which you can also describe as angle GAB. You can say it's GAB, right? Or you can also say GAC, or you can also say CAG, or you can also say BAG. Okay, so many ways of describing that. Or you can just call it angle A, because it's the whole angle. But if I were to ask you to describe for me the red part, that red part is not angle A. But instead, you can look at the V that is making up the red part. So that V would be this one. This would be the one. And therefore, you are looking at this angle here. Indeed. You are looking at this angle indeed. So how do you describe that red part, that angle there? You call it what? Angle GAD. You can call it angle GAD. Or you can also call it DAG, right? DAG. So those are the two ways in which you can describe that. This is because angle A itself, the big angle, is divided into different angles. So we need to be extra careful on it. Same goes for this part here. You cannot call this angle F. Like, you cannot call this part here. You can't call it angle F. Okay? We can't call it angle F because you must be careful. This red part here, please allow me just to do this. This part here, which is this angle there, just follow the V, right? If I look at the V, I can say it is this one. Ooh, just use a green color. So the V could be from here all the way to the corner at F, and then all the way to D. Then it means I'm referring to this angle. Now that angle can be BFD, or you can call it IFD, or you can call it HFD. You understand me? Or you can call it DFB, or you can call it DFI, or you can call it DFH, you see. Or you can even call it EFH, or you can call it EFI, or you can call it EFB. very important to name your angles properly. While this one here, how can we name that angle? How can we name that angle? Well, this we could say it is BFG, or you can say it's what, GFB, or you can even say GFH or GFI. You see, so many ways of describing it, but make sure that you understand that the angle is made up, is just the V there. Okay, right. So I hope that we have reminded each other on how to name angles, and we shouldn't struggle with naming angles. And then if I were to name this one here, how would I name it? What would be the name of that angle? Can you please just post for me in the group there, in the chat? What is the name of this angle here? What would you say is the name of that angle there? So this one there, well, a lot of ways in which you can name it. Yeah. Right, Miss Yolanda says angle AED. That's very much correct. So it is angle. So this one here, you can call it angle AED. Right, you can call it AED. Or you can also say HED, right? You can also call it HED, or you could say DEA, or you could say DEH. Okay, so those are our angles, and that is how to name the angles. Now, upon knowing how to name angles, right, then we have to remember our fun angles, right? So we have angles that we call the fun angles. This is because maths is fun, right? Let's say fun here. So let me just write it here. Yeah. So when we do a bit of recap on our grade 9 Euclid, we talked about maths is fun. This is how the learners were used to, be introduced to this, and most probably that F and U were written in this way. So they were written like this. Right, and then like this, and then like that, and then the fun part was like this, and then like that. Okay, this is how usually it's written, with an effort to say that here we have corresponding cointerior and alternating angles. That was the whole idea of writing the letters in this way, right? But for you, right, now that you are grade 12s, let's actually understand something first, right? What would you say are parallel lines? If someone was to ask you right now to say, Shanez, what are parallel lines? What would you say? I see Miss Katla was saying she can see. Please do confirm with me if you are able to see the screen. Okay. Okay, so it seems like most people can see. Please just check what's going on there, Miss Katla. If you're still facing the same problem, please do inform me. Right, so what would you say are parallel lines, right? If someone comes to you right now and say, yeah, and say, Alonde, what are parallel lines? What did you say? Miss Latita says these are lines that will never meet. Yeah, that's true. That's true. Does anyone have another definition apart from that one to describe parallel lines? All right. So yeah, that is true, AMM. Indeed, these are lines that will never meet. But now you are grade 12s. You need to have quite a different definition of this. So parallel lines, these are lines that are equidistant. These lines that are equidistant from each other or equidistant apart, and hence they will never meet. Right. So what we mean by that is that if I have a line here and then I have another line here, for me to call them parallel lines is because they are equidistant from each other. Now I'm going to quickly grab my ruler just to confirm that, and so that we understand what do I mean by equidistant. This ruler, exactly, it must be 270 exactly. So if I take my ruler here, right, and then I start to measure, right, yeah, this ruler is very slow but please be patient with it for a second. Yeah, so if I measure the distance here, right, if I measure the distance, it's giving me something like 4.1 centimeters. So it's giving me that the distance here is around 4.1. And if I move this ruler to the right, the distance does not change. It is still 4.1 throughout. So because the distance is the same between these two lines, right, which we got to be how much? 4.1 centimeters. So it means throughout it is 4.1 centimeters. Throughout it is 4.1 centimeters. Now because of this, these lines would be parallel to each other. That means they will never meet. Because how do lines meet? The lines are going to meet if it happens that the distance between them is not the same. For example, if I measure the distance here, it seems to be quite larger as compared to the distance here. So the fact that the distance here and that are not the same, it means the lines are not parallel. Because if I continue this line, at some point, it's going to meet with this horizontal line. At some point, trust me, they are going to meet him. Just that my screen is not really, or maybe I drew it not quite nice enough. But at some point, definitely, they are going to meet. Okay, so if I draw a straight line there, they're going to meet at some point. So that is why we say parallel lines, they do not meet and they never meet The reason is because they are equidistant from each other. They have the same distance between them. And this is actually quite a very important definition, because when you are dealing with grade 12 Euclid, you are dealing with triangles. Now you're going to work with triangles that are between parallel lines. Whoever is going to teach you Euclid, if they don't start with this definition, try to question yourself a bit there. I'll ask them why. Right. So that is what parallel lines are. So if you do have parallel lines, which is what we're gonna say we have here. So if we do have parallel lines, so I'm just gonna have my two parallel lines here. Here's one, and then here's another one. Now if you do have two parallel lines, and then you have what we call a transversal line, this one. What is a transversal line? This is a line that touches two parallel lines, meaning it's simply a line that you draw between two parallel lines. So that would be a transversal line or a transverse. So if you have a transverse or a transversal line, it will touch the two parallel lines. Because of that, you are going to have angles. Because before you had the transversal line, if I can remove the transversal line, do you have any angle between those parallel lines? You don't. There's no angle there. The angles are only there because you have a what? Because you have a transversal line. And now, what type of angles do we start to see? Because we have a transversal line, that's when we start to see angles that make an F shape, which are these ones here. And we say those angles are going to be equal due to them making an what? An F shape. These ones. So we're going to say what type of angles are those? We're going to say those are corresponding angles. Isn't it? So those are corresponding angles. Then that F shape is this one here. Right? So this is used for us to identify different type of angles that we have. So here and there, these are going to be what? Corresponding angles. But for a grade 9 learner, this is okay. For a grade 12 learner, you must be able to describe the F, its shape, itself. What I mean by that, you must be able to say these are corresponding angles that are equal only because this line is parallel to that line. So your F, you must label it with the parallel lines. Then what will be the name of this line? That's your transverse. That's your transverse there. That is your line that is touching the two parallel lines, you see. So you have a transverse and then you have parallel lines. That's why you're going to have your corresponding angles. And that F shape is the one that reminds you. So I'm going to label this and say this is AB and then say this is CD, right? So we can actually say now angle B, okay, we can simply say angle A. By saying angle A, I mean the whole angle. But this one, I cannot call it angle C. You can't call it angle C because if you say angle C, you are saying it's the whole angle, which is 180 degrees. You want only to describe this part, right? So that's why you should call it what? Angle DCE, or you can call it ECD. Okay, so those two are equal. Why? Because they are corresponding angles. And they are only equal because AB is parallel to CD. So you must state the parallel lines. This is already how we're going to answer our questions. Then this one, this, we're saying it's going to be equal to that. But only because this line is equal to that. And this is your what? This is your transverse line. Okay. So if we name this AB and then CD, we can definitely say now angle B will be equal to angle C. The reason because they are what? They are alternating angles. Which lines are parallel? AB is parallel to CD. Great. And then what about here? If I can name also this one, A, B, C, D, this line and that should be parallel. Then we will have a pair of what you call what? Co-interior angles. Now what do we say about co-interior angles? Instead of them being equal, when you add co-interior angles, the answer that you get is 180 degrees. So for co-interior angles, we're usually going to then say angle B plus angle C, not angle B is equal to angle C, but angle B plus angle C gives you what? 180 degrees. Your reason being that they are what? They are co-interior angles due to the fact that AB is parallel to CD. They are only equal to 180 because the lines are parallel. If the lines were not parallel, they won't be equal to 180. But does it stop them from being co-interior angles? For example, if I have this, imagine I have this. Right. It's slanted on purpose, by the way. I have A, B, C, D. This angle and that angle, good people, are they co-interior angles? Can you please just type for me there? Do you think those angles are co-interior angles? Yes or no? Are they co-interior angles? Yes or no? Snobile ma'am, I hope you're good after a long time. Are those co-interior angles? Yes or no? Okay. Right. Sparkly says no, while Miss Latita says yes. And then the rest. Right. Yeah. I have so many no's there. No, 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 no. Right. I think I have only, let's see. I think I have only one person who said yes. Right. That's very quite interesting. So, but thank you so much for that. So these angles here, good people, they are co-interior angles. They are co-interior angles. It's just that because they are inside, they are co-interior angles because they are inside the U shape. Okay, it's just that when you add angle B there and angle C, the answer that you get is not equal to 180 degrees. Why? Because AB is not indicated to be parallel to CD, and Loena, you can see that they are not parallel. So because the lines are not parallel, the co-interior angles, they don't add up to 180 degrees. They add up to a certain angle, but it's not going to be 180 degrees. Similarly, if I can ask you, similarly, these ones here, if I can draw a line here like this, and then I call it still, I say A, B, C, and D, right? Then I don't indicate that these things are parallel. Is angle B and angle C alternating angles? Are those alternating angles? The fact is yes, they are alternating angles, because the word alternating means that they are on opposite sides. They are alternating. So indeed, angle B and angle C, they are alternating angles. But are they equal? Well, angle B will not be equal to angle C. Why? Because AB is not indicated to be parallel to CD. The alternating angles, they are only equal if the lines are parallel. Similarly, good people, similarly, if I draw for you here, right, I say to you here, here's an F shape, and then I tell you that this is A, B, C, D, E. Then I tell you that here are your two angles. Is this angle and that, are they not corresponding angles? Well, they are corresponding angles because they correspond indeed. To correspond means that they are on similar positions. But are they equal? Is angle B equal to angle ECD? Are they equal? No, they are not equal. Your corresponding angles, they are not equal. Why? Because the reason why you are seeing all of this is because the lines are not parallel. So once the lines are not parallel, you will have alternating angles, but the alternating angles won't be equal. Because lines are parallel, you will have they are not parallel. You will have co-interior angles, but your co-interior angles are not going to add up to 180 degrees. But they will be there. We'll still call them co-interior angles, but just that they won't add up to 180 degrees. We will have corresponding angles. The corresponding angles, they will be there, but they won't be equal. Why? Because the lines are not parallel. So let's understand that corresponding angles, co-interior, and alternating are words that are used to describe the position of angles. Corresponding means the angles are on similar positions. Co-interior means your angles are inside the U shape. Right, they are interior angles. Co-interior, both of them are in the interior, inside. While alternating, it means you can see they're alternating. They form like a Z shape, you see. But they will be equal. Your alternating angles will be equal if the lines are parallel. They will be equal, your corresponding angles, if the lines are parallel. And then the co-interior are going to add up to 180 degrees if the lines are parallel. I hope that is clear. And why is it so important, right? Why am I stressing such a simple thing? You know, in life, those things that you take lightly are actually the most biggest things you can ever think of. The thing is that, imagine I give you a triangle right now. I've not taught you Euclidean Geometry, but I'm giving you the basics of Euclidean Geometry. If I give you a triangle right now like this, then I say there is an angle here, right? Then I'm going to call it theta. And then I say there's another angle here, then I'm going to call it theta. Then I can say this is A, B, C, D, E. Or let's just say I didn't give you that is theta. Let me just say I gave you a triangle like this. Right. It's going to be very, very sad if you find yourself saying that because you see an F shape here, right? You see, yes, I do see an F shape here. Nice, I see an F shape. So, bona, here are the corresponding angles. Then I run here, I say, okay, A, B, D is equal to angle C. Then I say, yeah, corresponding angles. Then I'm going to say, okay, state the lines that are parallel. Okay, BD is parallel to CE. Who said that? Who said that? They look, good people, looks deceive. I think boys, you know that much better, that looks deceive. Do not ever assume in Euclid, whatever you do in Euclid, do not ever assume. Please, please, don't ever assume to say, it seems like, no, 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 no. Because if you assume, you're gonna assume that the bridge that you built there is strong. You assumed that it's strong. But how sure are we that it's strong? You see, imagine would you drive on a bridge that you know that the engineer, when he was interviewed, he said, yeah, I assume that everything there is fine. I think everything is good. It looks okay. Would you drive on such a bridge? I think not. So what I'm just trying to emphasize is that unless there are these lines which show that the lines are parallel, do not assume that those angles are equal. So in this case, the angles themselves, they are not going to be equal. Yes, they are corresponding angles. I agree with you. They are corresponding angles, but they are not equal. Why? Because the line BD is not parallel to the line CE. Is that clear? I so hope that it is clear. Right. Because you're going to work with triangles. That is why I'm trying to emphasize that. Now, tell me something. Let's say again I have a triangle, right? Let's say I have a triangle, and then I'm just gonna call it triangle ABC again. I'm still going to have my lines here, but this time I tell you that this is 40 degrees. Ne? This time I tell you that this is 40 degrees, and then I tell you that this is 40 degrees. Let's call this D, and then let's call it E. If you check, angle ADE is equal to what? To 40 degrees. And then angle B is also equal to what? 40 degrees. Well, if both of them are equal to 40 degrees, therefore, can I not conclude? I can then conclude to say ADE, angle ADE will be equal to angle B. And I'll give a reason for that. The reason is because both of them, they're equal to what? To 40 degrees. That is why I'm saying they are equal. I'm not saying they are equal because, they are parallel lines and they are corresponding. No, no, no. I'm saying they are equal because both of them are equal to 40 degrees. So, if this angle and that are equal, what will that tell me about line DE and BC? I can actually make a conclusion to say, therefore, it means DE should be parallel to BC. So I will say, therefore, DE should be parallel to what? To BC. What is my reason? My reason is because the corresponding angles that I have, they are given to be equal. You understand me? So because I'm given that the corresponding angles are equal, I conclude to say that is only possible if the lines are parallel. So that is why I'm making a conclusion to say the lines should be parallel. Because there is no way that the corresponding angles will be equal if the lines are not parallel. You feel me? Yes. So that is why it's very much crucial to understand this. So understand that corresponding angles, they are there. Co-interior angles are there. Alternating are there. But corresponding angles are only equal if the lines are parallel. Alternating are also only equal if the lines are parallel. Co-interior, they add up to 180 only if the lines are parallel. So if I find a diagram whereby my corresponding angles are already equal, I can make a conclusion to say that the lines should be parallel. It's Sunday today. If I was in church, I'd say, go deeper, Papa. Yeah, but I hope that you understand me. Now, that is fine. So that means even if I can have a diagram here, right? Even if I can have a diagram, or let's have a circle. I found out today that I actually have a compass that I never used. Let me see if I can use it, guys. How do you use this thing? Aish. Yeah. Aish. I love it. This is beautiful. All right. So this is what we have here. Now I can't remove it. Yeah. So this is my nice perfect circle here. Now in that circle, I'm gonna draw a diagram. So let's say I have the following, and then I have the following, and then I have the following. Oh, let's do it like this, and then let's do it like this. Then let me say that this is an exterior. Oh, okay, no, it's fine. Let's say we have something like this, and then let's say we have something like this. Quite a complicated diagram. So let's say in this diagram, right, which is A, B, C, D, I'm just gonna call this 1 and 2. I'm gonna call this 1 and 2. Now let's say I tell you that angle D2 then is 30 degrees. Then I tell you that angle B1 is also 30 degrees. Good. If I say that, what type of angles is angle D2 and B1? Let's start there. I believe we can see that they do make some sort of a Z shape, right? They do make some sort of a what? A Z shape. And they appear to be equal. So I start again, right? I say angle B1 is equal to 30 degrees. And why am I saying that? Because it's just given in the diagram. You can see it. Angle D2 is 30 degrees. Why am I saying that? It's because it's given in the diagram. So that should tell me that if B1 is 30 and D2 is 30, that means angle B1 is equal to angle D2. It means this angle is equal to that angle. Why am I saying that? Well, because both of them are equal to 30 degrees. So wait a minute. By looking at them, the nature of the angles is that they are alternating angles because they make a Z shape. They are alternating. But we find that the alternating angles are equal. Well, because the alternating angles are equal, what can I conclude about the lines? Because the alternating angles are only equal if you have parallel lines. Well, this means AB should be parallel to CD. Why am I saying that? Because the alternating angles are what? Are equal. You can even write it because the alternating angles are equal. So the lines should be parallel. Now, two things. Someone is going to say, but now say, when I look at the diagram, it doesn't look like those things are parallel. They're going to meet somewhere. Then you know what I'm going to say? I'm going to say, remember the instruction says the diagrams are not necessarily drawn to scale. Okay, I understand that this instruction is because they want you to understand that you can't take a protractor and start, measuring there because the diagrams are not drawn to scale. But at the same time, it means that don't assume, don't assume that those lines are not parallel. Don't make a conclusion that the lines should not be parallel because you're looking at the diagram, right? It must be through logic explanation that we conclude that the lines are parallel. So when you're working with lines, you must say is both equals to 30 a real reason? Yes, exactly. It's a reason you should always use if two angles are equal to the same. For example, if I know angle D1 or B1 is equal to 60 and D7 is also equal to 60, I can conclude to say B1 and D7 are equal. And the reason why I'm saying that is because both are equal to 30 degrees. Please use that reason. Okay. So the way in which you are answering Euclid questions is that you are talking to the examiner. Okay, you are going step by step, explaining to the examiner logically that I see that B1 is 30 and you gave me that. I see that D2 is 30 and this is what you gave me. So I conclude to say that B1 and D2 are equal. Why am I saying that? Because both of them are equal to 30 degrees. And because both are equal to 30, it then says to me that the alternating angles are equal. So therefore I will conclude to say that the lines should be parallel, because alternating angles are only equal if the lines are parallel. I hope that is clear, guys. Any question from there? No question. Right. So I hope that the way in which we should logically explain things, I hope that we're actually getting it there. Okay. So that's how you're gonna explain things. Now, in terms of your theorems, now that you understand, parallel lines, and then alternating angles and all these type of angles, ne? So, you should then remember that the angles, the theorems in grade 11, right? In grade 11. By the way, guys, we don't have theorem 1, theorem 2, theorem 3. Yeah, but you're gonna say, but see, I was taught theorem 1, I know theorem 7. I know that theorem 7, you must have a circle and a tangent. There's no such thing. But what am I saying? What I'm saying to you is that don't name them, don't number them. I mean, do not number the theorems. Understand the theorems. Okay. But if you're a person who has always been able to remember them through theorem 1, theorem 9, theorem what, that is completely fine. But for me, how I want you to remember the theorems is that you can divide the theorems into 3 groups, which is C, C, T. Now, what is the first C? The first C is the ones that are talking about a circle. The second one is the ones that are talking about a cyclic quad. And then the third one is the one that are talking about a tangent. Now, interesting enough, this method of grouping the theorems, right? I discovered it through like studying the theorems themselves over the years. Then recently I looked at the Mind Action new textbook, the new Mind Action series. They are now explaining them that way. I'm like, wow, that's quite interesting. So you have 3 groups, okay? And this is the best way to remember them, trust me. The ones that are talking about circles, it's only 3 theorems. The first one is the one that says the line from center perpendicular to the chord, which is this theorem there. If you have a line from center perpendicular to chord, what does it do? It bisects the chord. And then the second theorem is the one that says the angle at the center is 2 times the angle at circumference. I'm giving them in a way that you would write them as resins. So this one there is the one that says the angle at the center is twice the one at the circumference. And then lastly, you have angle in a half circle. I like this reason a lot. So this is when you have a diameter. The angle formed by the diameter at the circumference is always equal to 90 degrees. Okay, those are the 3 theorems that are talking about a center, because you need to have a center to have those theorems. Did you hear what I said? You need to have a center to have those theorems. The ones that are talking about a cyclic quad, it's number 1, exterior angle of a cyclic quad. Yeah? The second one is opposite angles of a cyclic quad. And then last one is what? Is angles in the same segment. Okay. And then for tangent now, there are 3 of them. Tan perpendicular to radius. Number 2, tan chord theorem. And then number 3 is going to be tans from the same point. Those are your 9 theorems. And if you understand them in this way, you'll be able to answer questions nicely. Nice. Trust me, nice. So our session is about to end, but let's meet on Tuesday to work on the theorems there. Okay, I think I'll have them.